Okay, so just some little tidbits for the optical bench. So we're given some convex lenses and these concave lenses. So the convex lens you can rock, and like that. The concaves you can't, and if you run your finger on them, you kind of see that they're dished a little bit. You can sort of see it with the reflections there. So part of our lab is to try to understand what's the focal length of these things. And we're told that they're supposed to be a 5 and different kinds. And I tell my students that the ones, you notice this one is pretty flat. It's still convex. And so it has a large radius of curvature, and that means it has a large focal length. And then this one, it rocks more. And you can see it's bulgier. Maybe, you can see, yeah. And so this one would have a shorter focal length. So there is a quick and dirty way to figure out what is the focal length. So what we do is now we tip her up here, and so you'll notice there that we now have the screen that, and Dr. Burke, you may have seen a movie from Dr. Burke. So I have the screen here, and the important thing to notice is that I've got it way down there, and I got my light source way over here. And the light source, not only is it a light source, but it's also our image, our object, excuse me, and we've been looking at various images. So here's the cool thing. So I'm going to pause this, and you'll be back in a minute. Okay, now we're going to see something really cool, because I've set it up, as you saw earlier, with it very far away. And now, if we're going to zoom in, and what I've done is I moved this lens back and forth until I see the light source focus, and I can actually see the filament of the light bulb in there. So I know I'm in focus. And to further prove that I've got this as a faraway light source, we can see the image of the door across the hallway, and we could even see Miss Rose in the image. So now I know that I've got the screen at the focal point of the lens because I'm far away from the light source. And when you're very far away from any light source, even if it's a point source, you can say that you have parallel rays of light coming in, and by definition, all of the parallel rays will come to the focal point. All right, now, we go to the next step is I've moved the camera here because I want to zoom in. There's markings on the optical bench here, and there's notches in the holders, as you can see. So they give me a way of knowing where the screen is in relation to the object in the holder. So the lens one is pretty easy to understand. It's right down the middle. This one here, it has an adjustment, so you can move it ever so slightly. But you can basically see that the screen is in the middle. Okay, so what I want to actually do now is I want to actually zoom in on what's written there. And it's really nice. Of course, because we have glare, you can't see it. Let's see if I can shade it. And it's not focusing, unfortunately. So let's see if I can try manual focus. Wow, so it stopped recording, and I put it back to autofocus. And let's see. That's too bad. So what I wanted you guys to see is that it's at 0 here, and here it's at about 6.4. So what I do now, I can move this thing. I can move both of them so that without even looking at the image, I move this thing to 10 and I move this one to 16.4 thereabouts. And what I should notice is that the image is in focus again. And of course, right now the room lights are on and I can't see it. And I go back, and what happens is that when I was trying to zoom in and show you the numbers earlier, I bumped the lens. So when I moved the screen over to 10, I should have put the lens at 4.75, and then indeed I would have seen the image in focus. And you'll see I was pushing it closer just before the video paused. So now we've examined this one lens that has supposedly, well, we know now it's 5 centimeters, and notice it is pretty thick and curved. So let's verify what I said to you earlier, that this mirror, that's not, this lens of course, that's not very curved, has a longer focal length. So I shove this, I put this into the holder, and I put my retainer springy clippy thing here. And now let's set it up here. So we put the screen at 0 centimeters. And then we move our lens in and out, looking for the focus. Oh, and there it is. It'd be really tough to see this. I'm going to stop for a second. All right, so once again, we can focus this thing. And now, because this has a much longer focal length, one thing is we don't actually see the image of the doorway anymore. Now, what's too bad is that this thing is not focusing enough that you can actually, oh, now you, come on. Oh, I'm trying to get the camera to focus there because you could at least see the, yeah, now you can begin, you can see the image of the arrows that's on the front of it, but I can actually focus it so I can see the filament of the light. That's pretty darn cool. All right, so then if we look here, there's not enough light, so I'm going to stop this and turn the room lights back on, and oh, there we go. 24, about 24. See that? Isn't that neat? So that lens, that's much fatter, has a focal length of 24. And the other one that was, this one is much thinner and less curvy. That's 24. And the fat one was only 5. Pretty cool, huh? All right, so we had the fat curvy one. And we had the thin, very flat one. And that's the fat curvy one and the very thin one. And you can see that they sort of, I always tell my students that the curvier ones will tilt more. So the more curvy, the less curvy. And then there's an in-between here one that lifts a certain amount, but it's sort of not as much as this, but a little bit more than that one. So I'm going to take that one now, and I'm going to put it into my lens holder. And we're going to now set it on the optical bench once again. And let's see. And yeah, so look at that. It's actually in between. Remember, the first one was 4.75. And this one is telling me about 9 9.25 to 9.3. So in fact, it's in between. All right, so this is all consistent with what the lab manual told us to expect. So let's see if we can do an unknown now. Well, what happens is that this is a concave lens, and a concave lens is difficult to measure because it only forms a virtual image. So I'm thinking that I'm going to use my smallest focal length lens, and I'm going to pair it up with this guy here, and there's a formula in the book. Well, actually, you just add the focal lengths. Remember, the focal length of the concave diverging lens is going to be a negative number. So when we add the focal lengths of, oh gosh, I was stupid, I did this. So now I don't know, I have to readjust the height. But what I'm going to do here now is tilt the camera so you can see what I'm doing, or see what I'm screwing up. So I'm going to take out the one I just measured, and I'm going to drop in my concave, and I'm going to drop in my convex. I'm going to put this back, the clip back in, and now I've got to adjust the height once again, but that's not the end of the world. All I'm going to do is I'm going to bring it back over here by the light source, and then I'm going to just make it about the same height. And in fact, to make my life a little easier, if you want a straight line that are lined up in a certain way, it's better to do it with 3 points. So I have the light source, I have the lens, and I have the screen, and I noticed I needed to lift it up a little bit more. And now what I do is I go way down to the other end, and I'll rotate the camera to the end point. And now I move this back down here, and that's back at 0. And let's see if I can focus this thing. And there it is. And in fact, I have myself a converging lens that has a focal length of 5, and I have a diverging lens that I don't know the focal length of it. But I put it on here. I have my established technique of measuring the focal length, and this is pretty cool. As you can see, it's right at 8 centimeters. So now, with the known focal length of the convex mirror of 5 centimeters and the known and measured focal length, we can deduce the focal length of the concave. In fact, while we're here, I might as well do the other concave, and we'll have ourselves a full data set. Stay tuned. Right, so now what we're going to do is we're going to go ahead, and we have once again, our really thick 5 centimeter focal length lens. We have this particular concave, and I have another one here that actually, these two guys, yeah, if you look, they look the same. So let's see if I can find me yet a different one. Let's see. I have concave lens set here. No, this is calipers. Okay, so this one actually has its focal length written on it, but I'm not going to let you see it. But I'll get it out. And of course, you're going to have to take my word for it, but it's obviously thinner. And the only reason to make it thicker is so you can dish it, have it more concave, because it gets thin in the middle, right? And I can actually feel it, but maybe I can, maybe I can show you. I can take this straight edge. Yeah, you can see there's a little gap there, perhaps. And now I take the one that I claim is more concave. Oh, yeah, I mean, I can see it with my naked eye. But, it's hard to tell. But take my word for it, there's a much bigger gap there. Okay, so I'm going to take my holder, and I'm going to take my really curvy lens. I'm going to take my new unknown concave here that's not as dished in. And, it doesn't fit into the holder. This is a catastrophe because I really want to make this work. Let's see. So I'm going to stop this for a minute. All right, so Dr. Harry doesn't take no for an answer, so it's too bad I don't have duct tape, because that would be the best, right? But I found some, this blue masking tape, and all it has to do is last long enough for us to do our measurement. So let's hope that we don't break any equipment and get the lab tech mad at me. Okay, so we put this thing, set up the camera again. I put my lens in place in the holder, and I think what's happened once again is that the it's dropped down. That's all right. And now, and I kind of expect it because it wasn't quite as concave as before, and so it doesn't have as great of a negative focal length. And now, let's see if we can see it in the camera lens. We have a combined focal length of about call it 6.2 centimeters. There it is. Now you can sort of see it. You can see it quite well. And yeah, we verify that this guy's at 0 and that guy is at 6.2. Neato Kino, right? Okay, so we have plenty of information now to do all of our calculations. In principle, we have some other measurements of image and object distances.